We are with the third law of motion coming from our friend Newton. Newton's third law of motion is basically saying if an object A exerting a force on object B, then object B exert a force on object A that is equal in magnitude and opposite in direction. So we can represent that in letters. The directional force F of object A on B equals minus the directional force of B exerted on A. So you can see here, as you're pushing your foot to the floor while you are on the roller, then the roller will go to the right direction while your force exerted on the ground will go to the left direction. So in this way, the force that caused the motion called F action, or the force of action, and the force that is followed or replied as a consequence of the action force is called as the force of reaction. So you pushed your foot on the floor while the other foot on the roller, then the roller will go to the right and you'll be able to move in a certain distance to the right as a reaction to your force being pushed towards the ground. So F action going to the left, exact same force called F reaction going to the right, which is a representation for the Newton's third law as the force of A applied on B equals minus the force of B applied on A. Now in Newton's third law, there's two types of forces between objects. There's forces between contacted objects and there's forces between non-contacted objects. Example of forces between contacted objects means the object that is exerting a force is hitting or touching the object that is doing the reaction on that force in terms of contact or through contact. You can see here, volleyball player, you have the ball coming into his hand. He exerted a force of action to hit the ball this direction. That's called force of action. And the force of reaction would be exerted on her hands. If you observe a volleyball game, when the player hit the ball, there is a little reaction to his hand that will be pushed backward, especially if the applied force is high. So it is all force of action and force of reaction. That's the Newton's third law of motion. As you exert a force into a certain direction or a certain object, the object will exert a force as a reaction on you, and so on. Now the non-contact forces that we mentioned in Newton's third law, if you see an apple falling towards the ground, so there is a force of action going towards the earth through the gravitational force in this case, and there's a force of reaction from the earth on the apple. So when the apple falls on earth due to gravity force, then there is a reaction from the earth to the apple. That's why when you drop an apple or in a ball, it will keep bumping above the surface until it settles down eventually. Another kind of non-contact force between a magnet and a nail, or a magnet and another magnet. So the magnet is exerting a reaction on the action of pulling of that nail in this case. Let's take an example on Newton's third law in the ideal world, or in the real world. In other words, there is friction involved in all applications where you can observe the Newton's third law in natural life. But we will start with an example on how to apply Newton's third law in the simplest form. We will assume there is no friction. So in this example, we have three boxes. We have box A, box B, and box C. They are positioned next to each other on a horizontal frictionless surface. An applied force by hand acting on the box A will cause all the boxes ABC to accelerate at 1.5 meters per second squared to the right. It is asking to calculate the force exerted by box C on box B. So what is the force exerted on box C by box B? So you have ABC here, you push them to the right, each one have his own weight. There is no friction on the surface, you pushed a force to the right, and you know each box will push on the other box in a reaction force as a reply to the action force applied by hand. So we will start with simplifying things by breaking down given and required by the example. Given, we have the mass of box A 8 kilograms, mass of box B 10 kilograms, mass of box C 5 kilograms, acceleration of the whole system. If you remember when we talked about systems, the 3 boxes are whole system. The acceleration 1.5 meters per second to the right. Force exerted by box C on box B, so we can represent that as the directional force of C on B, or C-B, whatever you want. The important, you will imply what force you're talking about in terms of the other object. As you know, we start with the free body diagram. In this case, we will do free body diagram not for the whole system, but for box C. The mass of box C is known as 5 kilograms. Then we have a force to the right, FB on C. But we need to know what is the force FC on B, which is going to the left direction. You have the regular normal force, and you have the gravitational force pulling downward. You set your convention of directions. Right is positive, up is positive, left and down are negative. Box C is not accelerating up or down, so the vertical direction F net is 0. That's what we know. We write the equations to find the net force on box C in both horizontal and vertical. Horizontal direction, F net horizontal equals F B on C, and the F net vertical is 0. We ignore vertical in this case. If we apply Newton's second law, FB on C equals MC multiplied by A. MC is 5 by 1.5 meters per second squared, which equals 7.5 newtons. Now the FB on C directional is 7.5 newtons to the right. That's where the force is going. Now if we apply the Newton's third law, FC on B equals minus the FB on C. So that would be 7.5 newtons, not to the right, to the left, in the other direction. As simple as that. So you use the Newton's second law to find FB on C, but you use the third law to find FC on B, which is only change in the sign in this case, or in the direction of motion.